in this structure, NaCl goes under it. See, compare it. If this is A is Na, B is Cl. Is there if I would have taken the example of CaCl2, will it be possible on my part? How will it be possible? CaCl2, you see here, Ca, we can take Ca as A, it's okay. But is there Ab2? If it would have been Ab2, then we could have taken CaCl2. So Ab type means CaCl, which is not possible. CaCl, is CaCl compound existing? It is not possible. So NaCl, it is possible. As Na is A, Cl is B. So it is of Ab type. This structure is also known as the rock salt structure. So rock salt structure. NaCl is the rock salt structure. That NaCl is having the rock salt structure. Then, first thing we will study about it is in NaCl, Na plus ion plus Cl minus ion. Then it forms NaCl, as sodium means one loses, one gains electron. So Na plus plus Cl minus gives Na plus. In this way, if we see here, Na plus, this ion is present on the edge centers. Okay, this ion is present at the edge centers and it is also present in the edge centers and also on BCC arrangement, body centered cubic cell. So edge center, do you remember? In edge center, there are 12 edge centers and 1/4 per unit cell contribution. So it is 3 and body center is 1 on the middle. So BCC 1, edge center 12 into 1/4, which is 3. So the total is 3 plus 1 is 4. In the same way, if we see about Cl minus, in Cl minus, FCC arrangement takes place. This is FCC, face centered or CCP structure, whatever you can say. Here Z is equal to 4. Do you remember in FCC how Z is equal to 4 was going on? 1/8 into 8, 8 corners and 1/8 contribution per unit cell, plus 1/2 into 6. Those face means half contribution per unit cell and 6 faces, face centered 6 faces of the cube. So 2, if you cut it, cancel it, will come 3 and this is 1. So 1 plus 3, here also 4. So 4 here, 4 here. Therefore, it is NaCl as Na4, Cl4. In simplest form, you can write it as NaCl. Then, the next thing we will read is about the second characteristic of this arrangement. The second characteristic of this arrangement. The second characteristic is its coordination number is 6. We'll read about it, how it is being. The main thing is this concept. This concept is the main concept you need to understand. AB type, NaCl, rock salt structure, Na plus plus Cl minus, NaCl edge centers, 12 into 1/4, 3. Also on BCC 1, 3 plus 1, 4, Cl minus also 4, FCC Z is equal to 4. How it has been, I recalled you. If you don't remember these things at all, then please go to the previous videos and go back there and get understand there well. So coordination number is 6. A unit cell of this type means this AB type. A unit cell of AB type consists of 4 cell units. It consists of 4 cell units. Then see here, ionic radius of Na plus ion, it has its own value. R is 95 rpm. Sorry, I mean pm. Na is R is equal to 95 pm and Cl minus is R is equal to 181 pm. So radius ratio, how do you take out the radius ratio? The radius ratio is R by R plus by R minus. So 95 by 181, which will give you around 0.52. So 0.525 or 0.52 approximately, okay. So this type of arrangement goes under which kind of arrangement? I have said you octet 0.414, then those all things from 0.735 to 1, 0.414 are all those. So 0.525. Let me make you recall the table. Just pause the video if you don't remember it and recall the table if you want. So the table was 0.1552 to 0.225, then 0.225 to 0.414, 0.414 to 0.732, 0.732, then 0.732 to 1.0. Coordination number here, it was 3, it was 4 here, 6 here and 8 over here. This was trigonal planar, tetrahedral, octahedral and cubic. So here we have our range 0.525. 0.525, where it is? 0.1552 to 0. It is not here. 0.225 to 0.1414, it is also not here. 0.414 to 0.732, it is here. So 6, it is octahedral. This was trigonal planar. This was tetrahedral. This was cubic. Octahedral, cubic, tetrahedral, trigonal, planar. We have our value 0.525 within the range of 0.414R to 0.732R. So it's the arrangement of octahedral. Here the example is AB type arrangement, AB crystal type, NaCl, MgO, NaBr, CaO. Then trigonal planar, B2O3. This was ZnS type. The previous video it's all present, and in the cubic CsCl, CsBr. So our theme is NaCl, MgO, NaBr and CaO and etc. So octahedral arrangement. So from here we can conclude that this arrangement, AB type arrangement of NaCl rock salt structure, this has its octahedral type arrangement. So another point to add over here, it has octahedral arrangement. Then in that way, the next thing is about the anion Cl minus. Let me say you about the anion Cl minus. I hope you would be getting clear. Are you getting confused with these diagrams? Means this type of clumsiness. If you are getting, then please do write in the comment box and say me, then I will clear it out. The same part, the part which you are not getting. I hope it is clear, because I was saying and explaining, so it won't be that difficult. Still then, if you are facing any problem, then please do write on the comment box, so I will be able to know, else how will I be able to. So the anion Cl minus, I was saying about the anion. Let me draw here the line so it won't more be clumsy or complex. So about the anion Cl minus. In this ion of Cl minus, it is present at the lattice points. Do you remember lattice points and lattice sites? That was seen in the previous video. Lattice points of a face-centered cubic closed structure. Why face-centered? Because Cl minus is present, Cl minus ion is present at the face-centered, and Na plus at the epicenters and also on BCC. So lattice point Ca plus, Cl minus is lattice points of FCC. So FCC structure, Na plus occupying the octahedral voids. Na plus occupies the octahedral voids. Then each Na plus ion, if this is Na plus ion, this ion is surrounded by 6 Cl minus ion. 6 Cl minus ion, like this. So Cl minus ion here, 1, 2, 3, 4, 5, 6, octahedral void. So each Na plus ion is surrounded by 6 Cl minus ion. So each chloride ion is also surrounded by 6 sodium ions, the vice versa. So octahedral word coordination number is also 6. So this is a 6:6 arrangement. Remember this point. Let me say you. So this is a 6:6 arrangement. This is an important point. 6:6 arrangement. Then the next point. Radius ratio, I said you. The radius ratio also suggests that it has an octahedral arrangement. From this part we got about it, as this was our structure, and coordination number 6 is of octahedral, so that's why it is of octahedral arrangement. And it is also, this structure is also known as the rock salt structure. So that's why examples also I said you. So these are the important points. Oxides of alkaline earth metal, example MgO, CaO, TiO, Fi, FeO, NiO, all these are. So this was all about AB type arrangement. We covered the AB type arrangement. Then we'll see about the next arrangement or the next crystal structure. AB arrangement is not yet over, okay? In this AB arrangement only there are 3 types of arrangements. Like AB type first arrangement was about NaCl. The first was for NaCl. Now we will read about the next one of CsCl, cesium chloride. Cesium chloride. In this arrangement, BCC arrangement, how will I know that? In that FCC arrangement of Cl minus ion, remember that here BCC arrangement, coordination number is 8. I will explain you, okay? Don't worry. Just let me say you the important points. Then BCC arrangement, coordination number is 8. BCC arrangement, and the unit cell consists of only one CsCl. Only one CsCl unit cell. Then the radius ratio is around 0.93. RCS plus by RCl minus, it was around 0.93. So 0.93 means, let us get back to that. So 0.93, where is 0.93? It will go under 0.732 to 1. It will go under this one. Okay, so this will go here. So it has coordination number 8 and cubic. Okay, so cubic